Okay, what we have here today is a 12 volt power supply for camping. It's based on a basic battery box with a few extra added features that I've built into it. I had a look around online and looked for something that I wanted similar for powering a fridge and lights, etc. With an inverter, and I was looking at about $500 plus you had to buy a battery. Now I've put this together here, including the battery, which is a 60 amp hour battery, AGM, for about $300. So we've got the basic battery box, which comes with one 12 volt socket on the side, has a circuit breaker and a battery indicator, which, as we can see, we press the button, is showing full. It also comes with external terminal posts, which you can use to run jumper leads off, or if you wanted to charge with a solar panel, you can do that. So I've added a couple of extra things to it. I've added a 12 volt merit plug, which is used to power the fridge. I've added an additional 12 volt power supply there, and I've also added a twin USB plug power supply there, which, as you can see by the indicator light, is on, for charging your phone or whatever, iPod, etc. Now I've also added a inverter, which is a 300 watt inverter, and we switch the switch on there, we can see that it's active, and that will power 300 watts continuous sine wave. And I've also added a C-Tech battery charger with some ventilation holes on the side through the grill. I've also added an earth supply, earth stake there, which you just plug into the ground, which is off the back of the inverter. And to power the charger, I've added an IEC plug, which is just basically your computer plug, which just goes in there. I've also added an LED light, which we switch on here, which just gives a little bit of extra light if you need it when you're camping, as just an added feature. And I'll open it up and show you what we've done on the inside. We've undo the safety strap. And we can see inside 65 amp hour AGM battery. You can see the inverter, and we can also see the clamps for the battery charger, which are tucked away down here. I'll get them out in a second. Okay, now I've just disconnected the battery terminal leads from the battery, just so that we can see, open it up a little bit better and see what we've got. And I've also taken out the battery clamps for the C-Tech charger. Okay, now I've had to modify the inverter a little bit. It has this switch on the back, which was no good to me. I didn't want that there, so I needed to have it on the front. So what I've done is I've disconnected from the wires at the back here, brought the wires up through here and put them onto the switch here, and I've also run an additional earth lead back there, which gives us the LED light in the switch. Okay, the inverter is basically a 300 watt inverter available from Dick Smith, about $75 to $80. It comes with an earth terminal on the back of the unit, and that's why I've run the earth stake off that. Most appliances will probably be double insulated, but just in case they're not, we have that feature there, which just makes it a little bit safer. The C-Tech charger, it's an MX5, 12 volt, 5 amp. It will charge up to 110 amp hour battery, or it will maintain a 160 amp hour battery. Now it comes with two cables, one which has the eyelets which can go directly onto the battery terminals, or it has the clamps. Now at the moment I've chosen to use the clamps. I may change that later on. There is very little backfeed from the eyelets, so I could permanently connect them up to the battery terminals and just use it to switch on. But at the moment I've just taken and chosen to use the clamps. They just tuck away nicely down the side there, out of the way, and most times when you're going to be charging you're going to have the lid off anyway, so it's not really an issue. Now with the wiring on the unit, we have the original 12 volt power outlet here, which has its own inbuilt circuit breaker, which is wired to the external terminal post on the outside of the unit. You can see here I've got the merit plug which runs through, and that's running on a 20 amp fuse. Down here I've got the switch for the LED lights, and that's running on a 10 amp fuse. I've got my extra 12 volt socket here which is running on a 20 amp fuse, and I've got this one here which is running on a 7.5 amp fuse. And basically that's the inverter is also there, and it's running through this fuse block, and it's running on a 35 amp fuse. So we can see here we've got all the power coming into the fuse block, and then the power going out to the various accessories, and they're all in red, and then power coming back on the ground or the negative side is all in black. The USB outlet has its own individual fuse, basically because I bought a 4 block fuse block instead of a 5, and it had an inline fuse, and that has a 7.5 amp fuse in it. So all the accessory points are fused. The way that I've installed the inverter, I've just drilled through the front with a couple of pop rivets. On the side I've just pop riveted a bit of angle into the side of the unit, and with it fixed onto with the front with the double pop rivets there, and just a little bit of double-sided tape underneath the angle there just to hold it in place. I've also put some foam packing around the battery to keep it protected, also keeping the ventilation open here for the inverter to allow it to cool, but as you can see the battery doesn't move around in there at all. And I've put some little holes in the side there for the grill, so that we can dissipate the heat from the charger and the inverter. Here you can see the charger tucked away underneath of the inverter. You can see the ventilation holes in the inverter there as well. And that's actually just bolted through with 2 mounting points through the face of the battery box, and just all the cables are just neatly cable tied up out of the way. Here you can see the IEC plug. Now I've already thought of one modification which I'm going to do with that already. I'm going to change these, instead of to straight line connectors, to 90-degree connectors, and get that power a little bit out of the way from the back of the inverter. I'll put a little bit of double-sided tape there just to stop it rubbing and stop it contacting it, but just for safety I'm just going to change that a little bit. Now some of the things that if you're going to attempt to do this project that you'll need, you're going to need various electrical connectors, wire strippers, side cutters, screwdrivers, spanners, file. You're going to need a cordless drill, possibly a hot glue gun, assortment of drill bits, and you're probably also going to need a multimeter and a small spanner. All the components are readily available. I bought the battery charger online on eBay as the battery. The inverter I've had for a couple of years, bought that from Dick Smith. The battery box I bought from BCF, as did I did the light switch, the lights, and the other components, the cigarette adapter, USB adapter, the switches and the merit plug, all available at somewhere like Dick Smith, J-Car or Super Cheap, all readily available. So that's basically what I've done, and the reason I've done it is it cost me to buy a unit ready-made. It was going to cost me about $400, $500 plus buying a battery, which was $155. I've done the whole lot for about $300. So it suits my purposes, and I think it's a really good little project. I think it's something that will be useful, also be useful during blackouts as well as camping, and I hope you have fun doing a similar project. So thank you for watching.